Welcome back, my fellow programmers. Today we'll be talking about 4.2 for loops, another way to do iteration. Some of these examples might seem familiar, but believe me that repetition is in there as a meta way to demonstrate iteration. We will be starting off with a notional machine. Read the 4 lines of code on the left and try to execute it as if you were the computer. Starting on line 1, we have our for statement. You can see that there are 3 parts of the for statement. We have a variable initialization and declaration statement. We have a Boolean expression, and then we have an update statement. We are initializing I and setting it to 0, which we see in stack memory. Now this Boolean expression will be evaluated once every time the loop iterates. And the update statement will be evaluated once every time after the loop iterates. So we have I initialized in memory. That is a one-time execution. Now we go on to our Boolean expression. We are asking if I is less than 3. We are asking if 0 is less than 3, which evaluates to true. We go into line 2 and we're going to print out I. In the console, you see we printed out 0 because that's the current value of I. At the end of line 3, we are at the end of our loop. So we execute our update statement, I++, I becomes 1 in memory. We're back up at the top of the for statement again. We are evaluating our Boolean expression. This time I is 1. We're asking if 1 is less than 3, which still evaluates out to true. We get to step back into the for statement again. We're going to print out I. This time I is 1. That goes down in our console. On line 3, we are at the end of our for statement, so we execute our update I++. In memory, I becomes 2. We go back up to the top, we check our Boolean expression again. We are now asking if 2 is less than 3, which still evaluates to true, which means we still get to step into our loop on line 2. We're going to print out I currently is 2, so we'll get a 2 down here in the console. At the end of the loop on line 3, we do our update statement, I++. In stack memory, that 2 now becomes a 3. We go back up to the top, we check our Boolean expression again, I is 3. We're asking if 3 is less than 3. That's the first time this Boolean expression evaluates to false. That means we do not get to go back into the for statement. We will continue execution after the for statement is over on line 3. So we continue with line 4 where we print out complete. And so we will get complete in the console. That's going to bring us to our first topic, that for statement. Let's break it down and see what it's all about. Our learning objective: represent iterative processes using a for loop. So again, similar to with a while statement, you might have an algorithm or a task that you need to repeat over and over again, and we need a coding structure to do that for us. Now, previously, we have done that with a while loop. In order to use a while loop as a counter, there are 3 things that we need to make sure that we incorporate into that while loop. The first thing that we need to incorporate is an iterator declaration outside of our while loop. So we need a variable to track our account for us. We typically use I as that variable. The second part that we need is a looping condition that uses that iterator variable. And the third part that we need is an update statement that needs to happen inside the algorithm of the while loop. It's usually the last thing inside that algorithm. We need to move I in such a way that this looping condition will eventually evaluate to false and break the loop. Here we see 3 examples of 3 different while statements. The first one, we're saying while your password doesn't equal whatever your password should be, we're going to ask you to enter your password, and then we're going to capture whatever you type from the console. And then we'll check it again, and we'll keep checking it until you enter your correct password, which we all know is Pikachu. But you usually just have an @ symbol for the A instead of the A. The next one says, while your answer is not equal to 5, we're going to ask you a math question. What is 3.2? And then we're going to get an integer from the input stream, and we're going to put it in answer. And we will keep looping until you type a 5 for an answer. We'll just keep asking you this question over and over and over again. Our last one, we say, while you're not having fun, we're going to ask you if you're having fun. And if you say no, if you answer false, you're going to stay in this loop until you eventually answer true, saying that you are having fun. This demonstrates the main purpose of the while statement. While statements are great when you don't know how many times you are going to iterate. Since we are not using it as a counter in this time, we're not counting how many times you try to enter your password. We're not counting how many times you got the problem wrong. You see, we don't have those three parts. We don't have the iterator variable declared above it. We don't have the iterator variable in our looping condition, and we don't have the update statement. We are just looping until some certain condition is true. So here we see the example of using a while statement as a loop. We have our three parts. We have our iterator variable I. We're setting it to 1. We're looping while I is less than or equal to 10. And then we have our update statement where we have I++. So go ahead and take a moment and see if you can figure out what will be printed to the screen. So every time we loop, we're going to print the count, then we're going to print a period and a closing parenthesis. We start at 1. We're going to continue looping while we are less than or equal to 10, and we're going up by 1 every time. So we're going to print the numbers 1 through 10, but every time we print a number, we're going to put a period, and then we're going to put a closing parenthesis after it. So we can always use while statements as counters. We just need to remember to include those three parts. We're going to learn a new statement. That's going to be the for statement. The for statement is an iteration statement with the initialization condition and update statement built in that loops a fixed number of times. We have an example of that for statement down in the example box. It starts off with the keyword for, and then inside parentheses, we have an iterator declaration. We are declaring an integer named I and assigning it the value of 0. Following that, we have a Boolean expression that's going to be our looping condition. And then following that, we have an update statement. We might recognize those three parts as the three parts that we include in the while statement when we use that to loop a fixed number of times. And then finally, we have the algorithm that's going to repeat while that Boolean expression evaluates out to true. So on the top, we have an example of using a while loop as a counter, and on the bottom, we have our example of using the for loop as a counter. You'll notice that outside the while loop, we have our iterator. That's also the first part in our for statement. After the while, we have our looping condition. That's also in the for statement. And then inside the algorithm of the while, the last line in there, we have our update statement, which is also in our for statement. So the for statement is primarily used when you know the number of times you want to iterate. It has all three of those parts built into it. This aligns with our essential knowledge. There are three parts in a for loop header: the initialization, the Boolean expression, and the increment. The increment statement can also be a decrement statement. All what that means is that we are moving towards this Boolean expression evaluating to false. Looking at the three parts of the for statement, we have our initialization. That happens one time. That's to set up the loop. Then we have our Boolean expression or our looping condition. That happens every time before it lets us get into our algorithm. Before we loop again, we have to see if we can get inside this algorithm. Then we have our update statement. That happens every time after the algorithm has completed. To run through this code like the computer would, we first set up our loop using our initialization statement, int I is equal to 0. So I goes into stack memory as with the value of 0. That happens one time. We will not do that again for this for statement. Next, we have our looping condition. We need to do that before we get into the loop one time. We have to make sure that this evaluates to true. I is 0. We're asking if 0 is less than 5, and that evaluates to true. That means we get to go inside the loop and print I, and an underscore, which we see in the console. We printed 0 underscore. We are at the end of our loop, which means now we do our update and we're going to increment I by 2. So I is no longer 0, I is now 2. Since we are at the end of our loop, we now go back up to our looping condition and we check that again. Now we're checking if 2 is less than 5. That's true. We step inside, we print I and an underscore, so we print 2 underscore. We're at the end of our loop. We do our update statement. I becomes 4. We go back up to our looping condition. We're asking if 4 is less than 5. That's true. We're printing I and an underscore. That's 4 underscore. At the end of our loop, we update. I is now 6. We go back up, check our Boolean expression again. We're asking if 6 is less than 5. That's false. So then we continue after the for statement. We don't get to go back inside that for statement again, and we print complete into the console. On the left, you have a while statement being used as a counter loop. Write the equivalent for statement in the box on the right-hand side of the screen. What you need to remember is that the for statement condenses those 3 needed pieces. It puts them all on one line. We start off with int I is equal to 0. That's our initialization. We put a semicolon after that one. That's how we're going to separate these 3 parts. The next part, we put our looping condition. Our looping condition is while I is less than or equal to 10. Put a semicolon after that one as well. And then finally, we have our update statement, our I++. We do not put a semicolon after that one. Do not put a semicolon after the I++. You don't want to know what would happen if you do. It's nothing serious. It just doesn't work. So just don't do it. So now both of these are equivalent pieces of code. They both do the same thing. They both will print out the numbers 0 through 10 with an underscore after them. So we're starting at 0 for both of them. We're looping while we are less than or equal to 10 for both of them. We're printing the current number and an underscore for both of them. And then we're incrementing both of them by 1. So 0 through 10, all with underscores. And then finally, we'll hit that last line where we print done. This aligns with our essential knowledge. In a for loop, the initialization statement is only executed once before the first Boolean expression evaluation. The variable being initialized is referred to as a loop control variable. On the left, we have another while statement being used as a counter loop. Go ahead and write the for statement that will be the equivalent statement as that while statement. Again, we're just bringing over all 3 parts. We have our initialization, int x is equal to 1. Our looping condition, we're looping while x is less than 6. And then our update statement, we are adding 2 to x every time. All right, go ahead and determine what will be printed to the screen after this loop runs. It doesn't matter which loop, they are equivalent loops. They will both print the same thing. We're starting at 1. We are continuing while we are less than 6, and we're going up by 2 every time. That means we're going to print 1, 3, 5, and then once we add 2 to 5 and we get 7, 7 is no longer less than 6. We don't get inside the while statement. We don't get inside the for statement. Either way, we would print done afterwards. This aligns with our essential knowledge. In each iteration of a for loop, the increment statement is executed after the entire loop body is executed and before the Boolean expression is evaluated again. Looks like we got another while statement that we need to turn into another for statement. Go ahead and pause it and give it a try. Starting off with our variable declaration, int t is equal to 10. We're looping while t is greater than or equal to 4. And then our update statement is t minus minus. What will be printed to the screen? Well, we're starting at 10. We're going to loop while we are greater than or equal to 4, and we're counting down by 1 every time. This is going to be the numbers 10 through 4, and then we will print done. This aligns with our essential knowledge. A for loop can be written into an equivalent while loop and vice versa. Looking at these for statements, we need to determine how many times each loop will iterate. Starting with the loop on the left, we are initializing I to 100. We are looping while I is less than 10. This loop will iterate 0 times. We're starting at 100. We're asking if 100 is less than 10. That's false. We will never step inside and execute that algorithm. On the right, we have I is equal to 100 to begin with. We're looping while I is greater than 10, and we're adding 1 every time. So we're asking if 100 is greater than 10. That's true. And then we're going to add 1 to it. Then we're going to ask if 101 is greater than 10, and that's going to be true. And then we're going to add 1 to it. This will loop infinite times. We have a while statement on the left. We don't know how many times this while statement is going to run. It depends on how many times it takes the user to enter in the correct response. If we try to write that as an equivalent for statement, that's going to be a little bit tricky because the for statement is primarily used when the number of loops is known. It is a compact way of having those 3 parts in your loop. And the while statement works better when we don't know how many times we are going to loop. Here we have 4 algorithms. You have to identify how many of these are the correct algorithm to sum the numbers from 1 to 10. So we want to add 1 plus 2 plus 3 all the way up to 10. How many of them will work correctly? The first one, we are starting at 1 and we are looping while we are less than 10, and we're going up by 1 every time. This will sum the numbers 1 through 9. That will not work. The one on the top right, we are starting I at 1. We are looping while I is less than or equal to 10, and we're going up by 1 every time, and we're adding I into the sum. That's going to work. That's going to sum the numbers from 1 to 10. Looking at the bottom left, I is starting at 1. We're looping while we are less than 11, and we're going up by 1 every time, and we're adding I into sum. So this will go from 1 up to 10. This one will work as well. Bottom right, we're starting I at 1. We're looping while I is less than or equal to 11, and we're going up by 1 every time, and we're adding I into the sum. This will sum the numbers from 1 to 11. This one will not work properly. This aligns with our essential knowledge. Off by 1 errors occur when the iteration statement loops 1 too many or 1 too few times. That's going to take us to the end of this lesson. Make sure you rate how you feel about that learning objective. Read over your recap statements. Hit me up with any questions or concerns that you have regarding this concept. Join us in our next video and keep programming.